You're deep inside a battlefield. Drones are flying. The enemy's jamming your signals. You've got one shot to call air support, but how do you talk without anyone intercepting your call? Military radios use something called waveforms, advanced digital languages designed to survive war. Let's break down the key ones, with all the real tech specs. Let's start with SINCGARS, the single-channel ground and airborne radio system. Frequency range 30 to 87.975 MHz VHF. Channel spacing 25 kHz. Modulation FM for analog voice. CVSD at 16 kbps for digital. Data rate up to 16 kbps. Frequency hopping up to 100 hops per second. Encryption KY57 or equivalent. Type 1 ComSec. Radios and PRC 119 VRC series. Countries, US and allied militaries. Use case-secure tactical voice communication. Limitations, not suitable for high data throughput. Next, we have Quick, the waveform made for fast-moving aircraft. Frequency 225 to 400 MHz UHF, channel spacing 25 kHz, modulation AM, hop rate around 100 hops per second. Sync, GPS, time of day, TOD, word of day, WOD, encryption, KY58 external ComSec. Radios, ARC 164, ARCI 222. Countries, NATO Air Forces. Use case, secure airborne voice. Limitations, no native data support. Now, meet Link 16, the heartbeat of NATO's digital battlefield. Operating in the frequency range of 960 to 1215 MHz, or the L-band, it features a channel bandwidth of 3 MHz. The modulation techniques include MRE, FSK, DPSK, and CPM, with data rates ranging from 31.6 to 115.2 kilobits per second. Access is managed through TDMA, or Time Division Multiple Access. Encryption is secured with KG40A and KGV8, both Type 1. Synchronization relies on the Network Time Reference, or NTR, and it communicates using J-Series tactical data messages. Its primary use case is to provide shared situational awareness across multiple platforms. However, it does have limitations, such as high complexity and the necessity for time synchronization. The radios used include MIDS LVT and JTID's terminals, and it is employed by NATO, Japan, Australia, among others. Now let's go beyond line of sight with MUOS, Mobile User Objective System. This system operates in the UHF SATCOM frequency range from 300 MHz to 3 GHz, with a channel bandwidth of 5 MHz. The uplink and downlink modulations are QPSK and QPSK and 16 QAM respectively. MUOS supports data rates of up to 384 kilobits per second and employs end-to-end Type 1 encryption, approved by the NSA. The technology base is WCDMA, similar to 3G cellular networks. Radios like the AN/PRC 155 and PRC 117G are used with MUOS. Its primary use case is for global SATCOM voice and data communication. However, it requires satellite access and can experience latency issues. While primarily used by the US, it is expanding to include allies. Ever heard of Battlefield Wi-Fi? That's ANW2 Adaptive Networking Wideband Waveform. It operates in the frequency range of 225 MHz to 2 GHz, with bandwidths between 1.2 and 20 MHz. The modulation technique used is OFDM, and it supports data rates of up to 5 megabits per second. Encryption can be either AES 256 or Type 1. ANW2 functions as a mobile ad hoc network, or MANET. Radios such as the AN/PRC 117G and PRC 163 are compatible with this system. It is utilized by the US and NATO allies. The primary use case for ANW2 is to provide high-speed, self-healing networks, though it does have limitations like high power usage and a complex setup. Waveforms aren't just used, they're also intercepted. Enter the world of SIGINT, signal intelligence. Tools like GNU Radio, Wavecom, and SDRs enable capabilities such as demodulation, protocol recognition, and traffic analysis. Techniques include FSK, QAM, and PSK decoding, as well as jamming detection. SIGINT is used to analyze, spoof, or disrupt enemy communications. This is utilized by organizations like the NSA, GCHQ, and SIGINT Corps worldwide. Each waveform has its battlefield. Use SINCGARS for infantry. Have Quick for fast jets, Link 16 for data-rich coordination, MUOS for global reach, and ANW2 for mobile data nets. Choose wrong, and the mission fails. These are more than signals. They're survival tools in digital form. Which one impressed you the most? Comment below and subscribe for more secrets of military tech.